Okay, so far we have learned how seismic techniques can tell us about what's inside the Earth. Then we learned that gravitational techniques can tell us what's inside the Earth. So now we want to use electricity and magnetism to tell us what's inside the Earth. So first, let's talk about magnetism. And we said in a previous lesson that all magnetism is caused by moving electrical charges, even in a bar magnet. So inside of a bar magnet, you have the atoms that are spinning, and then as they are spinning, they are producing teeny tiny little magnetic fields. And then when you add all of those magnetic fields up, it gives you the overall magnetic field of the bar magnet. So all magnetism comes from moving electrical charges. And magnetism can cause forces. So you have the force of one bar magnet on another. So you know that the south end of a bar magnet is attracted to the north end of another bar magnet. You also know that electricity can make magnetism. So that was called a electromagnet. And so a bar magnet could be attracted to a electromagnet, and they could go together. So electricity makes magnetism, and then magnetism exerts magnetic forces. So how do we measure magnetism? So with this, it was called a seismometer. With this one, it was a gravitometer. And then with magnetism, it's going to be called a magnetometer. So a magnetometer is going to measure the strength of magnetism. So what can it tell you about the inside of the Earth? Well, it can locate metals, for example. So that if you have a magnetometer and you go over the top of a metal deposit, so it could be copper, could be lead, it could be gold. So any kind of metal is going to set off a magnetometer, and so we could use it to hunt for ores. We can also use magnetism to map the inside of the Earth, so that you would expect that since the magnetic field of the Earth does something like this, so remember this is a south magnetic pole up here, and then down here this is a north magnetic pole. And so the magnetic field of the Earth actually comes out of the South Pole, then it goes around and it goes back in at the North Pole. And then that's the reason why your compass needle, the north end of a compass needle, points north, is because the compass needle is aligning itself with that magnetic field. So you might get the idea that inside the Earth, the magnetic field should be pretty simple because it connects up here with down here, but it's not. Because inside the Earth, you've got convection going on. And so in convection, material is going up and then it's coming back down, it goes up and comes back down. So this magnetic field inside the Earth gets all twisted up. And we can actually map that twisting, and then from that twisting, we can actually work backwards, and we can see where materials are going up and then materials are going back down into the mantle. And all of this can be done by using magnetism. Okay, what about electricity? So what can that tell us about the inside of the Earth? Well, you got to know the difference between a conductor and an insulator. So a conductor conducts electricity. So a good conductor of electricity would be copper. All metals are good conductors of electricity. So anything that's a bad conductor is a insulator. So examples of insulators would be wood or glass or plastic. So all of these different things do not conduct electricity very well. So, a device that can measure electricity is going to consist of a battery that produces electricity, and then all you got to do is run it to a pole that you pound into the ground over here and then over here. And now what you need to do is you measure the electrical current between these two poles. And so if there's a lot of electricity traveling between these two iron poles, it's a good conductor. Now, what could be a good conductor? Water. So if there's a lot of moisture in the soil, that will conduct the electricity. On the other hand, let's say that there is a fracture in the ground right here, so that you got soil over here and you got soil over here, but now you got this big air space in between. Well, that's not going to conduct electricity very well, so that we can locate the location of faults by using electricity to do that. All right, so that concludes our review of geophysics. So come back and we're going to do another lesson for your review for the Unit 3 lecture exam.